Hello, welcome to everyone in this video. In this video, I want to discuss about the solution of the question which asked in University of Calcutta in 2021 for semester 3, that is CC5 Mathematical Methods 2 paper. At first, you try to solve this question. You can see there is a question number 1 A to G. After that, question number 2 and then question number 3, 4, 5, then question number 6 and 7. I request all of you, at first you try to solve this question. After that, continue the video to watch the solution of this question. Here I did not attend this part, that is the old syllabus part. This portion already included in other part. So for this semester I just ignored this question now 2025. Okay, so that's why we just continue with that portion and also neglect or eliminated this portion. So let's start to solve this question. Question 1a, we said find the average value of sin x plus sin square x within that region. So for any region, if you want to find out the average value, you just take the function integration and then the interval. So what is the value? 0 to 2 pi dx integration gives you 1 by 2 pi, and this is the function value sin x plus sin square x. Now if you just taking half, and 2 sin square x is 1 minus cos 2x, and if you taking the integration of this part, sin x is minus cos x half x and minus half sin 2x by 2. So after that 1 by 2 pi minus this one, just put this upper limit minus lower limit, you will be find out the average value as half. Next question say using generating function so that PL minus x equal to minus 1 whole to the power L PL PL of x, legendary polynomial. The generating function for legendary polynomial is 1 minus 2xy plus y square whole to the power minus half is equals to summation L equals to 0 to infinity y to the power L PL x. Now if you put this value x in place as a minus x, that is you put minus x in place of x, in both sides you will be obtain this expression, and again if we put minus y in place of y in equation number 1, you will be obtain this one. So you can see in equation number 2 and 3 left hand side same, so right hand side must be equal. After that, if you comparing the coefficient of this one, that is the minus 1 whole to the power L y to the power L P of L x equals to y to the power L P all minus x. So finally you will be obtain this relation. So next question, find the solution of this equation x square d2y dx square plus p of x dy dx plus q of y equals to 1, where p and q are the constant. So this is the differential, given differential equation. If we see for x equal to 0, this coefficient diverges, so this is the singular point. But if we multiply this one, and you will be find this are the finite, so we can solve this using the Frobenius method, and we take the general solution in the Frobenius method taking derivative, and if we put this value, we can get the coefficient of x to the lambda equals to like that, and there is no recurrence relation as the power is the same. So you will be obtain this lambda 2 value, then the solution will be like that, where lambda 1 and lambda 2 is this. Next question says for Poisson's distribution p of n equals to mu to the power n by n factorial to the power minus mu, find the standard deviation for this distribution, where mu is the constant. So Poisson's distribution is like that. So if you now if we want to sum of total, we will be get summation of this one. So this is put this value n equals to 0, then you will be obtained to the minus mu n equals to 1, this one. Just put this value here, n equals to 0 to infinity. So this is nothing but e to the power mu, so finally you will be obtained 1. Now for summation n p of n equals to gives you like that mu, and n square p of n gives you like mu 1 plus mu. So standard deviation is nothing but like 1. So just putting this value, you will be obtain root under mu. Next f of x tends to 0 for x tends to plus minus infinity. So find the Fourier transform of d of dx. So Fourier transform of this one is like that. Just taking the integration by parts of this was integration. This is derivative. You will be obtain this one and put this value at 2 points. This gives you 0 because at x tends to plus minus infinity f of x 0. So this portion gives you 0. You will be obtain this only, and this is nothing but the g of omega. So this is the g of omega is nothing but the Fourier transform of f of x. Next question says, so that x equals to 1 is regular singular form for legendary differential equation. The legendary differential equation is this one, 1 minus x square d2y by dx square minus 2x dy dx plus l into l plus 1y. So just divided this one on both sides. I will be obtain this standard form, and there is p of x is this one, q of x is this one. At x equals to 1, this is infinity, so this is singular point. Now if we just substitute this one, this is finite, and in case of this one also finite, so this is a regular singular point. X equals to 1 is a regular singular point in legendary differential equation. Next, so that for p greater than 0, gamma p plus 1 equals to p gamma p. This is the properties of gamma function. You know the integral form of gamma function is 0 to infinity to the power minus x to the power p minus 1 dx. So gamma p plus 1 is nothing but here they put p plus 1 instead of p here, you will be obtain x to the power p. Then if you integrating by parts, this is taking as derivative, and for that was integration, this function derivative, this function integration. So this gives you like that, and this is nothing but gamma p. So this is p gamma p, we obtain this, and this is 0 because when x equals to 0, this portion 0, when x equals to infinity, this is 0. Next question, consider the functions. So in this figure, find the Fourier transform g of omega, sketch g of omega versus omega. So for this function we can see for minus 1 to plus 1, this is value 1, that is mod t less than equals to 1, that is minus 1 to plus 1, and outside that one, that is mod t greater than 1, that is t greater than this region is we can say in this region t greater than 1, in this region t less than 1. So this is combined the t less than 1 and t greater than 1. Okay, and this is nothing but minus 1 to plus 1. Okay, so this in terms of mod we can write down this one. So the Fourier transform of f of t is g of omega, that is 1 by root 2 pi minus infinity plus infinity f of t, this one. And you can see all the above these are 0, only minus 1 to plus 1, the its value is 1. So if you put this minus in 1 to 1, and the others to integration is 0, and after that you will be integrating this one and put the upper limit minus lower limit, you will be obtain this one, and this is nothing but sin omega by omega. So if you plot this one, you will be gives this value when omega tends to 0, this gives limiting value root under 2 by pi, and for sin pi and minus pi, these are 0. So this nature of this curve will be like that. Next question says, so using Parseval identity 0 to infinity sin square omega by omega square d omega equal to pi by 2. Parseval in identity says that minus infinity to plus infinity, this integral of g omega square d omega is nothing but this one, where g of omega is the Fourier transform of f of t, where you can write that is the g of omega is Fourier transform, this is Fourier transform of f of t. So this is g of omega is the Fourier transform of f of t. From previous question we can see this is a from value of f of t, and g of omega is find out just last question, g of omega is like that and f of t is like that. So if you put in the both side, we obtain this expression, g of omega is this one and f of t is this one. You can see from minus 1 to plus 1, only one value is present, and the others is 0, minus infinity to plus infinity, other range is 0, only minus 1 to plus 1 is present. So this integration value is like that, so you obtain easily this expression. Clear? Next question, so that Fourier transform of f of t minus t0 is like that. We know the Fourier transform of f of t0 is nothing but function is written here, Now f of t is nothing but g of omega equal to like that. This is the formula, and you can see this f of t to the power, if we just multiply to the power minus I omega naught in both sides. After that, if you changing this limiting value t as a t minus t0, so this limit change is like that, and finally you obtain Fourier transform like that. Next question, using A and C, find Fourier transform h of t. You can see this the spectra is two interval just shifted from -1 to 4. So minus 1 to 4 is shifted here. So minus 1 to 3, that is minus 4 actually shifting in the right side. So Fourier transform h of t equal to e to the minus I omega naught t, this one, just t minus t0 like that. So this f of t is added one. So this will be the solution of this question. Next, calculate the using gamma function. This one I try to solve this question, but did not solve yet. If I can get, then I will be put in the comment section, or anyone have any suggestion, you must comment in the comment box for this question. Next, prove that the positive integer m and n beta mn is like that. Hence prove this one. We know the relation between beta and gamma function. This one, beta m comma n equals to gamma m gamma n by gamma m plus n, and we know the relation of the gamma function is like that, gamma n equals to n minus 1 factorial. So beta mn is like that. If we just rearranging this to up to 3 to 1, and after that we can see from this portion, this is m minus 1 factorial, so these two are cancel out, and this is written in reverse portion. So this will proved here. Now if we put m equals to 1 by 2, just put m equals to 1 by 2, beta half n equals to like that, just put m equals to 1 by 2 in here, and after that if you use this relation, will be get left hand side and right hand side, there is a 2 to the power n number, 2 to the power n LCM. So this is 1, this is 1 plus 2, that is 3, and so on. 1 plus 2n minus 1, that is 2n minus 1 minus 2. So this gives you, so finally you will obtain this expression like that. Okay. So you just check this. If there is any doubt, you must comment in the comment box. Next question, given f of x equals to x for x equals to 0 to 1, sketch even function corresponding to this function with period 2. Find the Fourier series in the even function. For even function with periodicity 2, this will be the nature, will like that, and you know the Fourier series formula, Fourier series of f of x in this formula, where a0 an bn is like that. Now here you can see a0 is just put this value 2 by the limit is minus 1 to 1, so 1 minus of minus 1, that is 2, and f of x dx from minus 1 to 1, and there is a break at 0, so minus 1 to 0 and 0 to 1. For minus 1 to 0 this is minus x, and for 0 to 1 this is x, and integrating value is 1. Similar in case of an, this will gives you for odd value of n, this is 4 by n square by pi square, and for even value this is 0. Just you can see for these two are even, so you just integrating will be like that. I think you can do this integration, just integration by parts. And in case of bn, this is 0 because f of x is even function, and this is the sine function is odd function in this region. So from the integration properties of integration minus u to plus a, this even function and odd function multiplication gives you odd function. So the for odd function this total integration will be 0. Hence the Fourier transform series will be like that. This is odd function, that is sine part, bn part is 0, only an part and a0 are present here. Using the above equation, find this value. So the final expression we obtain, f of x equals to half summation of this one. So at x equal to 0, and here n is the odd number, so we just put this value, f of x is 0, at x equals to 0, you can see this function is 0, at x equals to 0 this function is 0. Put this 0, and this is half, and since n is odd value, so just put this value of odd value 1, 3, 5, 7 and so on. So you will be obtain this. So this is the answer. Next question is sketch the odd function of periodicity 2 of the given function. if this is this was the even function, but this is the odd function, because when x is reverse, y also, that is f of x also reverse. Next question, from the generating function Hermite polynomial, this is the generating function, so that this property, this is already discussed in theoretical class, that is e to the power 2xt minus t square is like that, differentiating in both sides with respect to x, this gives you 2t, and it exponential this one, and with respect to x, so this is hn prime x. Okay, and this is nothing but this one in the summation form. Then if you comparing the coefficient of t to the power n, here t to the power n gives you n minus 1, right? So there is a 2 and hn minus 1, and this is t to the power n is like that. So finally you obtain this relation, because this is n into n minus 1 factorial. So n minus 1 factorial cancel out. So if you find 2n here. Next question. H on x is orthogonal polynomial in the domain minus infinity to plus infinity, and suppose h to x equals to a plus b x square. Find a and b using orthogonality property of h and x, and given h0 x is 1, h1 x is 2x, and coefficient of highest power of x is h and x is 2 to the power n. So this is the orthogonality property. The coefficient of highest power of x h to the n is 2 to the power n. So this is h to x, so highest power will be 2 to the power 2, that is the 4. So this is 4x square plus a, if you consider another constant a, so the b value of b is 4. Now using this property, orthogonal property, with 0 with 2, because with 1 and 2 this gives you odd function. That already 0 because in the integral property, but when we take h0 and h2, this is not a odd function, so finally you obtain this value of a. Next question, solve this equation using Frobenius method around x equals to 0. Using Frobenius method, we can take that solution in the summation form like that. If you take its first order derivative, second order derivative, and put within this equation, and comparing the coefficient of x to the lambda, you will be obtain the value of lambda equals to 3 minus 2. And if you compare the coefficient of x to the lambda plus 1, you will be obtain the value of lambda minus a0, lambda value minus 3 2. Hence for lambda equals to 3 and minus 2, a1 can be written as 0. Okay. Now compare the coefficient of x to the lambda plus k, you can see there is no recurrence relation. Hence the solution will be lambda equals to 3 like that, for lambda equals to minus 2 like that. So they are linear combination also a solution. So this will be the final solution of this equation. I think you understand this one. Just put this value lambda equals to 3 here, and the coefficient k, there is no recurrence relation, so only a0 term is present here. Similarly for that one, a0 term present here. So these two linear combination give in another solution. This is the two solution, y1 y2 are the solution, and their linear combination will be another solution. So final solution will be written as like that. Next, for a binomial distribution in with n trials, p is the probability of success and q is the failure, then so that the mean and variance of the distribution respectively np and npq. The mean distribution will be find out like that, and if you put p of r is this is the binomial distribution, we can say this one nothing but the binomial, this is binomial distribution. Okay, so using this binomial distribution, and after that this can be written in this form, and finally you will be obtain this is a np. Actually these are the discussed in theoretical class, you can check in the playlist button, you will be obtain the different playlist. And for the variance, you need to expectation value of n square and square of the expectation value of n. So for that, this is already find out np. For that one, you just taking this type of calculation, you find out the npq plus n square p square. So sigma square equal to npq. Okay, so you just do this calculation, you will find out this result. Next, solve this question using Fourier transform. So this is the given equation, and taking the Fourier transform in both sides with this integration sinusoidal Fourier transform, and left hand side gives you this integration will like that, for right hand side this will like this one, and if you right hand side this one, even these two equating this one and this one equating, and finally you will obtain this relation. Next question, a random variable x has a density is like that constant, you need to find out the constancy and the probability for x greater than 1. So the total probability must be 1, the total probability must be 1. So minus infinity plus infinity f of x dx equals to 1. If you put this value f of x dx equal to c x dx, which is 1, so this gives you x square by 2 like that. If you put this upper limit minus lower limit, you will be obtain the value of c is half, and the probability for that for x greater than 1, that is x equals to 1 to infinity f of x dx. So value of f of x is cx within this region only up to 2, after that this is 0. So the upper limit will be 2, not infinity, because after 2 this is 0. So after that you will be obtain this expression x square by 2 integration, and upper limit minus lower limit gives you 3 by 4. Next question, the heat equation of 2 dimension Cartesian coordinate is given by this. This is the partial differential equation. Solve this equation for steady state using method of separation of variable. For partial differential equation, solution can be made using separation of variable. So this is the 2 dimension heat equation, del to t by del x square, del to t by del y square, and so on. Take if you take t equals to, which is function of x, y and t, just taking the partial derivative with respect to x and then again derivative, you can see when we derivative with respect to x, y and t are the constant, that's why these are constant, and the partial derivative transform into exact derivative, because this capital X only function of x, right? So similarly for y and similarly for t. So using this equation in 1, you will be obtain this type of relation, and finally if you divided by x, y, t, will be this relation, and this right hand side taken as minus omega square, and this is also minus x omega square. So this portion taken as minus omega x square, this portion taken as minus omega y square, and their solution is common like that. So steady state solution in the multiplication of these 3 portions. Sorry. Find the solution u x of t boundary value problem is like that. Given this is relation. So this is the partial derivative. For that you need to solve using separation of variable, right? So there is 2 function x and t, so take separated by these 2 function, partial derivative. When you take del u del x, you will get t dx by dx. So taking again derivative, this one, putting this in equation number 1, separate out, this is omega square. Sorry, there is a omega square. And separated out, you will be obtain t and x, multiply, this is the general solution. Now we need to use the boundary condition which are given here, that is u0 t is 0. So if you put here 0 and x value 0 is, this is 1, this is 1, so a plus b, so a equals to minus b. Put this value, you will be obtain this type of equation. After that, using the next boundary condition, and we obtain the value of omega, and the solution will be like that. Then use the another boundary condition, and you will be obtain the value of a. Okay, so finally will be obtain the total solution. I think clear. This step just I find gives you the path of the solution. It did not explain each step. If there is any doubt to understand any step, you must comment in the comment box. So this is all about me. Presently I work as a scientific assistant at Dum Dum Airport under RNC Kolkata, in the IND, India Meteorological Department, Earth Science, Government of India. And this is my contact details, and this is my YouTube channel. So take care. We will meet in the next video as soon as possible. Thank you.